Okay, here we're going to be taking a look at practice question number 3. So the instructions were for each problem, write what you are finding or looking for in probability notation. It says to label a normal curve with relevant values and shade the area of interest, the area we're finding the probability of. C says to show the calculator commands used to compute your answer. And D, make sure to actually answer the question and answer it in a complete sentence. So the question we're working with, number 3, says for salary workers with an advertising firm, the yearly salary is normally distributed with a mean of $42,100 and a standard deviation of $4,800. What proportion of these workers earn less than $34,000 per year? So they've given us the scenario about salaries from this firm. They've told us the mean salary is $42,100, and they're asking us to figure out, and given that, what proportion of these workers actually have a salary that's less than $34,000 per year. So the first thing it asks us to do, part A, said write what you are finding in probability notation. So what you're finding, that you want to look at what specific question is being asked after they've given you the information about the problem. So here they're asking what proportion of these workers earn less than $34,000 per year. So to write what we're finding in probability notation, it's always going to start the same with a capital P, P for probability, and in parentheses, what we're finding the probability of. And in this case, we're looking for what's the probability that we get a value for our random variable x that is less than 34,000. So that's what we're looking for. What's the probability that a random value for this variable is less than 34,000? What's the probability that a random worker earns less than $34,000 per year? B says to label the normal curves with relevant values and shade the area of interest. So when they say relevant values, here they haven't specifically laid out. Make sure to label X number of standard deviations. So how many standard deviations you want to label is up to you. But at a minimum for the relevant values, you need to label the mean and the value you're finding the probability for. So in this case, that would be the $34,000. And last sort of minimum is to either label at least one standard deviation or right above the curve what the standard deviation is. So In this problem, the standard deviation was $4,800. So that would look like this. I'm going to right by the curve say that sigma, or each standard deviation, has a value of 4,800. So that would be the minimum for the standard deviations, is just to write that in. So if you wrote that in, labeled the mean, the value you're finding the probability of, that would be sort of the minimum and would get you full credit for labeling relevant values. So while you don't have to necessarily calculate out what each value for each standard deviation is, I do find that it's helpful to do that, because then I know where to place or label the value we're looking for. So I'm going to start by labeling the mean. Here they said the mean was $42,100. So mean, that always goes in the middle. And I'm going to write it a little sideways because the numbers are longer, just so I have more room. So our mean is 42,100. If I wanted to then label the standard deviations above and below the mean, I would use the standard deviation and either add it to the mean if I'm moving to the right, or subtract it from the mean if I'm moving to the left. So if I move one standard deviation here to the right, I'd have 42,100 plus 4,800, and that would give me a value of 46,900. And then to find the value of the second standard deviation above the mean, I would just add 4,800 to this value, which would get me 51,700. And the third standard deviation above the mean would have a value of 56,500. Okay, as we move to the left of the mean, we'll be subtracting 4,800. So if I subtract 4,800 from 42,100, that would give me 37,300. That would be the value of one standard deviation below the mean. And I'll keep subtracting 4,800 each standard deviation I go. So 2 standard deviations below the mean would have a value of 32,500. And 3 standard deviations below the mean would have a value of 27,700. Okay, so we have our mean and all of the standard deviation values labeled. Next thing we want to label is the value we're trying to find the probability of. We were trying to find what's the probability that a random worker earns less than $34,000. So I want to label where 34,000 is here on the number line. And that's why I like to calculate out what each of the standard deviations are, so I can make sure that I'm accurately placing where that value, in this case 34,000, should be located on the graph. So 34,000, that's going to be between these two values, 1 and 2 standard deviations below the mean. So it's somewhere around halfway between 32,500 and 37,300. So I'm going to make a tick mark there and label it with 34,000. Okay. Last thing I need to do in terms of labeling the graph. It said to shade the area of interest. So the area we're interested in is the area that is less than $34,000. So we just labeled where 34,000 would be. I'm going to make a vertical line up to the top of the normal curve at that spot. And because we're looking for less than 34,000, I'm going to shade the area to the left, or the values that are, in fact, less than $34,000. Okay. Moving on to part C. C was to show the calculator commands you used. This isn't something I'm going to require you to do on the test. Usually all students are using the same calculator and all have the same specific commands to answer a question like this. But I know some of you are using different online tools that may have different instructions as to how to enter the commands to come up with the answer. I'm going to write down and go through what the steps or commands would be on a TI-84 graphing calculator. So in a question such as the one we're working on, where they're asking us to find the area of a value that's not a given or specific standard deviation value, we're going to use what's called the normal function on our calculator to help calculate the exact proportion or percent. So if I were writing calculator instructions, first thing I would write down is the word normal. And the letters C, D, F. How you get here on a graphing calculator is to hit the second button and then one that's on the right towards the top that says VARS. So I'm going to zoom it out for a second. So if this is my calculator, the second button is on the upper left, and the VARS button I'm looking for, VARS, is right here. And by hitting the second button first, that's going to take us to the distributions menu. So we're working with probability distributions. So I'm going to hit second VARS, and I'm given a list of different distributions I can choose from. And you'll notice at the top there's two different options for normal PDF and normal CDF. And you want to make sure that you're selecting number 2, normal CDF. So I will arrow down so number 2 is highlighted, and then I'll hit the enter key. At this step, depending on what version of the TI-84 you have, these words, lower, upper, mu, sigma, might show up. or you might just be given a blank set of parentheses. Either way, you're going to be entering a series of 4 values. So regardless of what version you're working with, you're going to end up with 4 values with commas between them inside a set of parentheses. The first value you're entering is what's called the lower bound. And the lower bound is the smallest value our variable could have in terms of the area we have shaded. So the lowest value would be furthest left. And you recall earlier I mentioned that this normal curve, it keeps continuing on forever and ever in the left direction and in the right direction. So as we move to the right, the numbers continue to get larger and larger and larger and larger and larger and larger, and it never stops. So we say that these values are going to go to infinity, and in this case, positive infinity. These values are getting bigger and bigger and bigger. However, as we move to the left of the distribution, the values will continue to get smaller and smaller. Eventually, they'll become negative and more negative and infinitely negative. So we call the far left bound negative infinity. Okay. So in our case, our lower bound is negative infinity. That is the smallest value possible in this shaded area we're focusing on. Second number you enter is going to represent the upper bound. So this is the largest possible value your variable can take on. So to determine this, I'm going to look back at the space I have shaded in my normal distribution, and I want to find the biggest number in the shaded area. So the shaded area, as I move to the right, it goes all the way up to 34,000, and it stops right there. So the largest value, or the upper bound for this shaded area, would be 34,000. The next 2 values in the set of 4 you're going to enter are easier to determine. So the third value you enter is always going to be mu, the population mean. And the fourth value is always going to be sigma, the population standard deviation. So lowest value, highest value, mean, standard deviation. I'll write that in. Okay. So one other part you're going to need to know to enter these values, if either your lower or upper bound contains either positive or negative infinity, you need to know how to type positive or negative infinity on a calculator, because they actually don't have a button for that. So on your calculator, to enter either positive or negative infinity, you want to look for the button that above it to the left has two capital E's, EE. So since that's not the actual button, to get to EE, I would have to first hit the second button and then the comma. So if you're trying to type in positive infinity to your calculator, you're going to type a +1. You're going to do second comma so that you're getting that EE button. And behind the EE, you're going to type 2 9s, 99. If you're trying to enter negative infinity on your calculator, it's almost exactly the same, except instead of starting with a +1, you're going to start out with a -1. So I'm going to do -1, second comma to get the EE, and 9, 9. So that's how you enter either positive or negative infinity on a graphing calculator. So if I were to write the calculator instructions, assuming I'm working with a graphing calculator, I start with normal CDF. That's the function we need to calculate. In parentheses, I'm going to write the 4 values I need to enter, starting with the lower bound. So our lower bound, our smallest value, is negative infinity. And the shorthand for writing negative infinity is -1. And then you just use 1 E to represent that double E. But you want to be careful when you're doing that on the calculator that you're not looking for the key that has a single E but a double E. So this is my lower bound, negative infinity. And then I'm going to put a comma. Next value is the upper bound, so the largest value in the shaded area, which was 34,000. I'll put a comma. Third value I need to write down is what mu, the population mean, is. So remember our mean here was 42,100. Fourth value, our standard deviation. So in this problem, the standard deviation was 4,800. So I'm going to clear my values real quick. So just to go over all that from start to beginning on the calculator, I'm going to start by hitting second vars, second vars. That brings up the list of distributions. I'm looking for the distribution titled normal CDF. So I will highlight that, hit enter. And again, depending on what version of a graphing calculator, they'll either give you these specific 4 words, or it might just be a blank set of parentheses where you're just going to enter each of those 4 values with a comma separating them. So first thing I'm going to enter is the lower bound, which we said was negative infinity. So again, to enter negative infinity, I'm going to start by typing a -1. So I'll hit the negative key and then a 1. And you want to make sure you're hitting the negative key and not the minus key, because you won't get the same answer. So I have my -1. Next, I'm looking for that double E, the EE, which is right here above the key for comma. So I'm going to hit second and the comma button. And you can notice, even though you were selecting the double E, it shows up as just a single E. And then 2 9s, 9 9. So then I'll either move down to enter the upper bound, or if you have just open parentheses, you would type in a comma and then the value for our upper bound. So our upper bound, the largest value in the shaded area, was 34,000. I can move down to mu, the mean. If you have the blank open parentheses, you would just put another comma. So mu, our mean, we said was 42,100, comma, last standard deviation, which was 4,800. And on this version of the calculator, I'm now going to arrow down so it's highlighting the word paste and hit the enter button. And here it pops up all the values we just entered. And also, if you have a different version of the calculator where when you went to normal CDF, it didn't give you those helpers, lower, upper, this is exactly how you would have typed it in, or how it should have looked. You have your negative infinity, comma, 34,000, comma, the mean, comma, standard deviation, comma. Now I'm just going to hit the enter key, and it's going to give me a long decimal. So I get 0.04575, and it keeps going. So because it keeps going, we're going to need to round it, and you want to make sure that you're going out to the third place behind the decimal. So I'm going to have 0.04, and then I have to decide what to do with the 5. Because there's a 7 behind it, I'm going to round it up to a 6. Okay, so that is our answer, 0.046. That is the area of this shaded region under the curve. This area is equal to 0.046. And that's also the probability that a given worker earns a salary less than 34,000. So when we write our final answer to this question, we do want to convert our proportion to its percent form. So to change this to a percent, I just need to multiply by 100 or move the decimal 2 times to the right. And so we would end up with 4.6%. So if I were to complete the last requirement of the question D, answer the question in a complete sentence, I might say something like, about 4.6% of salaried workers with the advertising firm earn less than $34,000 per year. And it is important that you're being really specific and you're writing out all those descriptors. Again, you can check the answer key to see the sentence I wrote. So you can double check and make sure you're including all of the information.